Hi everyone, I'm delighted to be here today to show you some exciting macros my team has built with dbt and how they've improved efficiency and data quality in Snowflake. And I've also tried to keep time at the end for any questions. So for those of you that don't know, macros are a piece of code in dbt that could be reused. They're basically like functions. They can be brought into models and also run independently. So before I get into the exciting bits, I'll introduce myself. I'm Naomi. I'm Director of Data Platform at Lyst. Lyst is a fashion technology company and premium shopping app. We're the largest global fashion search platform that aggregates products from thousands of fashion stores into one website and app to simplify the process of finding and shopping for fashion. I head data platform engineering and analytics engineering, and as I'm sure you can guess, part of our data platform includes dbt and Snowflake. So dbt released their State of Analytics Engineering report earlier this year. And in this report, there were 3 areas of importance that were highlighted for a large number of companies. So the first being data quality, where majority of data professionals find this the most challenging when they're preparing for analysis. And this importance has increased year on year by 17 percentage points. And the second is being able to ship data products faster, where majority of data professionals see this as an important priority for the business. And the third is reducing cost. The macros I'll be discussing today that we've built have been able to improve all 3 of these areas of importance for businesses. As a team, we're constantly pushing the limits, and if we think something is possible, we try and do it. And from that, these great solutions have been built. They've had both immediate positive impact on the business, as well as supported larger pipeline revamps and migrations. And I'm hoping that this will inspire you to try and build these macros, or try and build other exciting macros that will improve your project, your workflow, and your impact of analytics engineering at your company. So today, I'll be talking about 2 macros: the business problem we had, our tactics, and then the impact of the macro on the business. The first is our primary key testing macro, where we've improved the traditional approach to primary key testing, improving data quality while simultaneously reducing runtime and cost. And the second is our dbt DAG in code. This has had multiple use cases since we created it. The first problem we solved with this was to improve data accessibility by identifying and removing unused parts of our dbt project. So let's get into the first macro. So how do primary key tests normally work? As I'm sure many of you know, a table's primary key should always be unique and not null. And every company I've worked with, as I'm sure many of you do, have the primary key test in the schema YAML file using dbt's pre-built not null and unique tests. But what challenges were we finding with this solution? So when I first joined the company, there were a number of issues that were regularly occurring. Firstly, our dbt jobs were taking longer and longer to run each week due to the primary key test taking longer and longer to run. We have a number of large dbt models that run on very large warehouses, and we were finding that the uniqueness test took a considerable number of minutes to run. For those that aren't aware, your tests in your schema YAML file run on your profile's default warehouse, which would often, for us, be a small or a medium, often 3 to 4 times smaller than the warehouse that the model was running on. And the second is that these tests scan the full table, which could be many gigabytes big. So a lot of our tables are huge, and we'd have the uniqueness test would have lots of spillage because it wasn't the optimum warehouse, and it would be scanning large amounts of unnecessary data. So to give you an example, we had one incremental model that would take 2 minutes to run on a large warehouse. The uniqueness test would take up to 60 minutes to run. And then when the primary key test failed, the table was then polluted, which would then take time and money to fix, particularly for these large tables. So the majority of our models are incremental for efficiency, and because our table is very big. And when the primary key test failed, these models would then be polluted with erroneous data. It would either take a long time to try and remove this incorrect data, taking an analytics engineer away from their work, or we'd have to rebuild the table from scratch, which would cost us a large amount of money. And finally, developers need to remember to add these tests to the schema YAML file. So if an analyst or another non-analytics engineer was building a DBT model, there was a risk that they would forget to do this. So how does DBT run? When DBT models run in Snowflake, the pre-hooks, the model, and the post-hooks all run on the model's warehouse. But the tests which run at the end use the profile's default warehouse. And we wanted to solve issues with this. Firstly, we wanted the primary key test to run on the same warehouse as the model. Secondly, we wanted to scan only necessary data while still making sure that the test was 100% accurate. Oh, sorry. For incremental models, we wanted to test before the table gets updated, and then only update the table once the tests pass. And finally, we wanted to reduce dependency on developers needing to remember to add these primary key tests. So how could we test the data accurately before updating the table? And how can we get the test to run on the model's warehouse? We needed to consider different model types, but we knew it was possible. It was all about finding the solution. So firstly, talking about tables, views, and when incremental models run as full refreshes. So in these cases, it would be okay if the table was polluted, as they often don't take long to run, if we do need to rebuild them. So we needed to create a solution where the model's warehouse was used. So we extended the unique key parameter that exists for incremental models to also be used for tables and views as well. And then we created a macro that automatically runs uniqueness and not null tests based on this unique key as a post hook on all models of these types. So as the test was now a post hook, it would run on the model's warehouse, and extending the unique key meant that the primary key test would happen automatically without a developer needing to remember to add the tests. So what does the configuration look like for different model types? So as I mentioned before, for tables and views, we extended to use the unique key, which is used for incremental models. For incremental models that merge, the unique key is the primary key, and so we just test this. For delete and insert incremental models, the unique key might not be the primary key. So to give you an example, you might delete and insert on reporting date, but your primary key might be a combination of reporting date and user ID. So for this case, we created a new unique test key, which would be the primary key, and then we test this. And for insert incremental models, where there's no unique key, we use the new unique test key as well. So the most exciting bit of this macro is how we use it for incremental models when they run incrementally. So for those that don't know, when an incremental model runs incrementally, DBT will first create a temporary table or a view of the new data, and then we'll merge, delete and insert, or insert into the production table. So we customized DBT's incremental model macros so that the primary key macro that we created would run as part of the model run. So it runs after the temp table or view is created on only necessary data, and then only updates the production table if the primary key test passes. And this solves all of our challenges. The tests run on the model's warehouse. It only scans necessary data while still being 100% accurate. If the test fails, the table isn't polluted. And the primary key test is automatic based on the model configuration. So I'll go through how we do this for merge incremental models. And this also works for delete and insert incremental models where the primary key is the unique key or contains the unique key. So for these models, we know that the production table will have passed the primary key tests. So when the temp table or view is created, we only need to test this new data. This is because this new data will either be appended if the primary key is brand new, or will overwrite the production row if it already exists in the production table. So if this is unique and not null, when it then gets merged, the production table will still continue to have unique and not null primary keys. And if the test passes on the temp table, we then update the production table. And if it fails, we then save that data as a view to use for debugging. And then the production table isn't updated, and then we fail the model. I'll skip how we do this for delete and insert only incremental models due to time. So if you would like to hear about this, please reach out to me afterwards. So this has had significant impact on development, runtime, and cost of running DBT. It's improved data quality through automatic testing and not polluting production data. Developers don't need to remember to add primary key tests, and if the test fails, the table isn't affected. And it's reduced runtime and cost. So to go back to that previous example, we had one incremental model that would take 2 minutes to run on a large warehouse, and the previous primary key test would take up to 60 minutes to run. With this new solution, the tests take 2 minutes. And on average, our primary key test runtime has dropped 99% from 172 seconds to 2 seconds. And this is an average saving of nearly 3 minutes per model run. And finally, we can ship products faster because we spend less time fixing data issues. In terms of iterations, our first version didn't save the erroneous data, which would then make debugging more of a challenge. So now we save this data if the test fails. So the second macro I'll be showing is our DBT DAG in code. So last year, similar to other businesses, we looked to identify opportunities where we could reduce cost by removing inefficiencies. So we got together as a team, and we brainstormed ways in which we could do this. And one of the suggestions was to find unused parts of our project, i.e. tables that weren't being used by anyone in the business. We could then disable these, remove the tables, which would then save run cost and storage, as well as reduce complexity of our DBT projects. Our focus previously had been building new models or improving existing models, and we hadn't really focused on removing parts of the project that were no longer needed. So this was a really good opportunity for us. So in order to do this, we needed to know what tables weren't being used, and then also make sure none of the children were being used either. So in this example, we would want to identify returns and returns daily as models that we could remove. And we had some specific criteria for this project. The first was that we wanted to automate the process of identifying the models that we could remove and then have this run on a regular basis. And then we wanted to calculate the estimated saving from storage and runs so that we could report on cost saving and also prioritize the work accordingly. And finally, we then wanted to automate removing the table from the production database once the DBT model was disabled or removed. So how could we do this? So in order to build this solution, the first thing we needed was to find these models programmatically. So we created our DBT DAG as a table. For those that don't know, DBT has something called the graph context variable. It's basically a dictionary that has every node in your DAG with lots of other metadata, such as the parent models that are referenced in that model. This feature has loads of opportunities to elevate your project, And this is one way that we've used it to build the DAG as a table, but there are definitely more opportunities to use this data. So we created a macro that extracts all of the data for the sources, the models, the snapshots, and the seeds with information such as the parents, the pre-hooks, the post-hooks, and the materialization. And then we needed to find, for every node, all of its parents and all of its children with the degrees of separation. Fortunately, Snowflake has a really cool feature called the recursive join, which basically loops through every join. So we built a model that takes this macro, runs a recursive join to get every child-parent relationship in the DAG with the degrees of separation between the two models, as well as all of the other useful metadata that we'd extracted. And then the macro and the model run after every pull request merge so that we have the most up-to-date production DAG. So using the same example as before of the orders of returns pipeline, you can see below that we have a row for both orders and orders int relationship with 1 degree of separation, as well as orders and orders raw with 2 degrees of separation. And if there are any parts of the DAG where 2 models are multiple degrees of separation away, we have a row for each one. And then with this and Snowflake query history, we could find how much each model is being queried, and then also check if any of its children are being queried as well. So now that we have the DAG as a table, the next thing was to estimate the cost-saving potential by calculating how much we could save from dbt production runs when we actually stop running these models. So the first thing we needed was to calculate cost per query. So Snowflake has a query history view, which has all the queries that are run in Snowflake with additional data, such as the model that was used, the warehouse that was used, and the runtime. So with this, we created a model that saves this data and then pulls out metadata, such as the dbt node ID, i.e. the model. For those that don't know, Snowflake doesn't bill based per query. It bills based on how long a warehouse is on for. So we then needed to estimate the cost of a query based on this. Unfortunately, select.dev, who's in the booths over there, so please go speak to them, actually has a calculation for this in their blog. So we use this to add a cost estimation against each query in the table. And for those that don't know, earlier this month, Snowflake now provide a view of credit per query, but that doesn't take into account idle warehouse time, which this calculation does. So next, we then needed to calculate the cost of a production dbt run for a specific model so that we can then calculate the savings. So we used dbt artifacts dbt package, which saves data about every dbt cloud run. And then we built dbt models from this. For our nodes, i.e. the models, the snapshots, etc. that are run. Our runs, i.e. the specific runs, which could have 0 to multiple nodes run. And our invocations, i.e. the commands that are run in a run. And then we enrich this with our query cost estimation to calculate the cost of running a specific model in a specific run. And finally, with all of this, we could then build the process of identifying and removing unused parts of our pipeline. So firstly, we have a dbt model that checks if a table's been queried in the last 60 days, and we exclude certain users or tools like analytics engineering and data observability tools. If it hasn't, we then check we use the dbt DAG table to then check if any of the table's children have been queried. And if the table hasn't been queried and its children haven't been queried, we then have a monthly alert to the analytics engineering team to then disable the equivalent DBT models. And then once these models have been disabled, we then have a macro that checks if the table has been queried and if the table has an enabled DBT model. And if both are false, it then automatically moves that table to an archive database where we keep it there for a period of time before it's permanently deleted. And then this is a screenshot of an example of our alert. So now this process is run monthly to spring clean our project. Before I go into impact, I'll discuss iterations. So firstly, the DAG was originally updated daily, but in order to keep it up to date with our production project and also ensure that it wasn't running unnecessarily, we now run it after every PR merge. Secondly, we've added column and model description data to the DAG table so that we can report on description coverage at a column, table, and schema level. And finally, we've used this DAG table to support updating pipelines. So we've updated a model or rebuilt part of a pipeline. This table enables us to find all of the children models that need updating. And then the materialization alongside the query, the cost estimation, helps us quickly figure out the best way to update the table, whether it's a dbt build command or a Snowflake update query. And then with a query that we've developed with this DAG table, we can also order all of the models so that we know in what order to run these downstream models. And this is particularly helpful when you have a mix of dbt build commands and Snowflake update queries. In terms of impact, in the first month of this spring clean process, we saved nearly 10% of our dbt cloud Snowflake costs. It's reduced cost and complexity of our data pipelines with no impact on the business. The DAG as a table has enabled us to update our pipeline and ship data migrations faster and more efficiently. And the track description coverage has increased trust and understanding of our data across the business. dbt announced yesterday that they've released a feature in dbt Cloud to understand if a model's being queried. But for our use case, we needed to exclude analytics engineering as well as some tools like data observability, which their feature currently doesn't include. So in summary, use macros. Macros can be really powerful, unlocking opportunities for both new and existing processes. If there's something you can do in your data warehouse, you can likely automate it with a macro. And there's also potential opportunities to customize how dbt runs and customize your project to work more personalized to your business. I've discussed 2 of our many macros at Lyst that have improved data quality, reduced cost, and enabled us to ship faster. I'm keen to hear about any cool macros you've built or macros you're now thinking of creating. Thank you. Do you want to ask anyway? Yeah.
This is really cool. Thank you. I was wondering, have you found that the code that keeps the DAG table updated is expensive to run itself?
It's really cheap. It's very, very small. The macro, even if you had thousands of dbt models, if you think about the size of the table, it ends up being very, very small. And so it's very, very cheap. Yeah.
Thank you.
No worries.
I'm curious what BI tool you're using and if you're, because sometimes when you do these types of cost optimization, you
Yeah, it's a really good question. So we use Looker as our BI tool, and there obviously is some caching involved, but it is maybe, maximum a day, depending on how long a table's been updated. The fact that we look for like 2 to 3 months of usage, the likelihood, I think, for any BI tool to be cached for that long, there's probably a bigger issue going on if you're caching data for that long. So for us, the big thing is we want people to have enough time to query the data and for us to not just get rid of it, if it is something that gets used monthly. And that's why we also have an archive database, which only analytics engineering have access to. So we move it there quietly. We leave it there for about a month, see if anyone shouts. If no one shouts, we then drop it. If people do shout, we can bring it back, and then updating that table doesn't end up being too expensive.
That works really well.
Amazing talk. Thank you so much. I actually have a client that had a Christmas dashboard that was only relevant during Christmas.
Yeah.
And we got into a lot of trouble for deleting stuff thinking it wasn't used in 6 months. Do you have any custom way of creating exceptions for these very weird cases?
Yeah, so in the macro, you could very easily explicitly say, ignore these tables. So we have one specific schema that is really only ever used by analytics engineering. It's called our audit schema, and it has things like query history, the dbt cloud, run tables, and things like that. We exclude that schema completely because we know that we're using it, and we also know that we're gonna get rid of stuff if we don't need it anymore. So yeah, there are ways to basically filter out specific tables or schemas if you'd like to.
And a quick one. I might know the answer, but are these code samples available anywhere?
Not at the moment.
I thought so.
But I'm hoping that there's enough in the slides to give people direction on where to go.
In the dbt graph that you used for identifying which nodes you can eliminate, did you have any cases where you ran into cyclic dependencies? Sometimes there can be cyclic dependencies in the tables, and that can cause some problems.
So for us, no. If there are dependencies that are going around, I don't think dbt would run with that. And if it does, then I think I would probably suggest getting rid of those because you'll end up with very complex DAGs with a lot of issues. So I'd say if you are finding that, get rid of them, and then this won't be a problem.
All right, I think we have time for one more question.
On your primary key macro that you're running on incremental models, you said you were running it essentially on the temp table that it's creating, right? How are you then calling that? So it's not a part of the post hook, right? Because that's after creation.
So it's actually the incremental macro that dbt has built. We've edited that.
Okay.
So it ends up running after the temp table or view is created, and then we'll only do the merge, delete and insert, etc. if that ends up passing. And if it fails, then the model ends up failing.
Okay, thank you.
All right.
I think that's a question for dbt.
The question was, can we share the slides? I am actually not certain. This might be recorded. I can get you an answer for sure. Okay, yeah, so the slides and the audio will be uploaded to YouTube, so you can catch it there. If anyone does have any more questions, feel free to find Naomi. But otherwise, can we give her one last round of applause?